Proprietary alloys and a dedicated gas trader for Texas facilities show SpaceX tightening control over Starship materials and energy inputs. This is SpaceX Daily, episode 79. SpaceX has replaced the 301 stainless steel used in early Starship prototypes with proprietary alloys in current flight vehicles. The change addresses specific performance needs in high-temperature and structural loading environments during ascent and re-entry. Earlier test flights relied on 301 steel for its availability and weldability, but the new alloys enable tighter margins on mass and thermal properties. Observers note the shift reflects iterative material qualification that began after initial flight tests exposed limitations in the baseline alloy. The update appears in production ships now reaching the launch mount. Production decisions now incorporate alloy performance data gathered across multiple prior flights. The move supports ongoing efforts to refine vehicle mass properties without altering external geometry. SpaceX has brought on a gas trader to manage fuel and feedstock supply for a Texas chip fabrication facility tied to Starship production. The role focuses on securing natural gas and industrial gases at scale for both semiconductor manufacturing and engine test operations. The facility supports internal compute hardware needs while also feeding Raptor engine development and vehicle assembly. Hiring signals an effort to internalize energy procurement that previously relied on external suppliers. The move aligns with ongoing expansion of production infrastructure in the region. Procurement responsibilities now include direct negotiation of pipeline volumes and spot market hedging. The position reports into operations supporting both the fabrication line and nearby test infrastructure. Worth keeping an eye on is analyst commentary on the Falcon wind-down timeline that highlights execution risk if Starship flight rate does not scale as projected. The concern centers on whether the transition can occur without interrupting national security and commercial launch commitments already on the manifest. Resolution depends on achieving the several times per week cadence described as the trigger for the shift. Market participants continue to monitor regulatory and production milestones that would confirm the projected handoff remains on schedule. On the AI front, no new source developments appeared today on the SpaceX XAI Grok Cursor compute thread. The live threads to watch remain orbital data centers, direct-to-cell backhaul, XAI compute scale, and Cursor Grok distribution. From an engineering standpoint, SpaceX's decision to move Starship from off-the-shelf 301 stainless to proprietary alloys begins with the raw material cost floor. 301 steel is inexpensive because its chromium and nickel content is modest and its processing is mature, yet it imposes limits on allowable stress at the temperatures reached during re-entry and on the thickness needed to survive plume impingement. By developing in-house alloys, the company trades higher initial material expense for reductions in vehicle dry mass and in the number of thermal protection tiles required, directly lowering the propellant mass that must be lifted to achieve the same delta V. The idiot index here is the ratio of finished alloy price to the cost of the constituent metals plus melting energy. Any gap above that floor comes from qualification testing, certification, and the supply chain steps that remain outside the raw inputs. Closing that gap through vertical integration of melting and forming is the same logic that drove earlier moves to build Raptor turbopumps and avionics in-house rather than buy them at catalog prices. The next measurable step will be whether the new alloys allow a measurable drop in tile count or a higher propellant load on the same gross liftoff mass, both of which compound across every subsequent flight. Flight data from recent vehicles already incorporate lessons from earlier alloy trials, confirming that incremental qualification cycles can be completed without halting the overall test cadence. The gas trader hire for the Texas chip plant follows the same first principles path on the energy side. Natural gas is the lowest cost feedstock for both process heat and on-site power generation once pipeline access and offtake contracts are secured. The trader's job is to compress the spread between spot prices and the delivered cost inside the facility fence, shrinking the multiple between raw energy input and the kilowatt hours that ultimately reach silicon or test stand pumps. If the plant produces chips for flight computers or ground support systems, every dollar saved on gas flows straight into lower marginal cost per vehicle or per launch. The same accounting applies to Raptor test firings that consume large volumes of methane and oxygen. Locking in feedstock pricing reduces the variable cost that otherwise scales with flight rate. Over time, the approach mirrors the containerization parallel. Standardize the input commodity, control its logistics, and the downstream hardware cost curve bends downward. Facility planners can now model total energy spend as a controllable variable rather than an external exposure that fluctuates with regional demand. Both moves converge on the same constraint. Starship's economic viability at high cadence depends on collapsing every non-propellant cost element. Alloy substitution attacks structural and thermal mass. Internal gas trading attacks energy cost. Each reduces the effective idiot index of the delivered vehicle. The open variable is how quickly the new alloys reach flight-proven status and whether the gas contracts can be structured at the volumes required once Starship operations move beyond the current test tempo. Continued iteration on both fronts will determine whether the per-flight cost trajectory remains steep enough to support the target reuse rates. Observers will watch for the first public indication that either change has produced a measurable reduction in vehicle mass or test stand operating expense. A quick look at the tape shows the stock closing modestly higher. Before we go, the first public indication of measurable mass or operating cost reduction from either material or energy change is the item to track next. That's your SpaceX news for today. SPCX is trading at $136.97, up 0.2%. If the show saves you time, a rating or review on Apple Podcasts or Spotify genuinely helps new listeners find it. I'm Patrick in Vancouver. Thanks for listening. See you tomorrow. One more thing. If you liked today's episode, our sister show OmniView is worth a spot in your feed, a balanced daily world news briefing that takes every side seriously. It's one of the NARA Network's daily briefings, all free at naranetwork.com. The Do Positive Pod is the club for people who do something about it. Episodes and the dispatch wall at naranetwork.com/thedppod. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.